Alright guys, so today we're going to be finding area between curves, but here's the catch, we're doing it without calculators today. So let's go ahead and jump in and begin our first problem here. Alright, so I've given us a graph here, but we don't really need the graph. I'm going to reference it occasionally just for teaching purposes, but really you're not going to have a graph because we're doing it without calculators, and calculators are how we get those in the first place. And we're never going to take the time on an AP Calculus test to sketch the graph of something. That takes far too much time. So we're going to be working without graphs. So how do we do this? Well, the first step is we want to find where the two functions intersect. If you know where the two functions intersect, then you know where to set your integral up at, right? You know that those are your endpoints going from A to B. That's where they intersect. So how do you do that? Well, the way that you find where two functions intersect is by setting the functions equal to each other. So I would take the first function and setting it equal to the second function. All right, so now these are polynomials, and when you want to solve a polynomial equation, you need to get everything over on one side so that it equals 0, and that way we can factor it and use the zero product property. Stuff we've been doing quite a bit this year, actually. All right, now we got a factor, and as you guys can see, there's a greatest common factor here. They all have an x in common, so anytime you see a GCF, it's a good idea to start by taking the GCF out before you do anything else with the factorization. And now I want to factor this polynomial here. So we're going to use our good old-fashioned box method here. Put your first term in the top left corner. You put your last term in the bottom corner. And what we do now is we ask ourselves what times what will make x squared. And really there's only one option, it's x times x. And then next we ask ourselves what number times what number will make negative 8. Now there's a few options there. It could be 4 times a negative 2. It could be negative 4 times 2. It could be 8 times a negative 1 or negative 8 times 1. And really you don't know what the correct answer is, so your best bet is just to pick one and see if it works. Okay, so I'm going to just randomly pick one here. So I'm going to go with 8 and 1. Now, here's how we know if our guess is right. You're going to complete your box, and when you're all done, the two numbers here should be like terms that add up to make the middle number of your trinomial. The only part we haven't put in the box yet. If they don't, then something's wrong. So let's see. What goes here would be 8x, and what goes here would be 1x. And 1x and 8x don't even begin to get close to 2. So that we've got a wrong answer there. So I'm going to get rid of those then. So my guess of, one of those was supposed to be negative, but I'm pretty sure we still won't get the right answer. Yeah, so that makes a positive 7. That's no good. We want a positive 2, so that doesn't work, right? So what we got to do then is we're going to pick a different pair of numbers. So let's try 4 and 2. Negative 4, positive 2. And the reason I'm taking time on this is because I know a lot of you guys are still struggling with your factoring. So, all right, now let's see if this works. Negative 4x and positive 2x. Well, if I put those together, I get negative 2x, but I want a positive 2x. Now, nice little word to the wise here. Anytime you get the right number but the wrong sign, it's a very simple fix. It's really just as simple as changing the signs of the numbers you've already picked. So for instance, I did negative 4 and positive 2. Well, let's try switching the signs. So in other words, it's going to be that one. And that should do it. So really it's just a guess and check strategy. You just got to keep going until you get there. And sure enough, now I've got 4x minus 2x. That does add up to make the middle. And so we have now successfully factored that trinomial. And so the answer will be x minus 2 and x plus 4. All right. After you factor it, you're going to go ahead and set each piece equal to 0. So we're going to have x equals 0. We're going to have x minus 2 equals 0. And then we're going to have x plus 4 equals 0. And then we're going to solve all three. Now this one's already solved, but this one we got to add 2 first. And on this one we've got to subtract 4. And those are my three values of x where these two functions would intersect each other. Now I'm going to bring back the graph here for a minute. Once again, we're not going to have the luxury of looking at one, but just for teaching purposes, that would mean right here is where x equals negative 4. Right here is where x equals 0. And right here is where x equals 2. So those are my 3 points of intersection, and that's step 1, is to find those points of intersection. And you don't need the y values. And the reason we don't need the y values is because, as you guys can see, we're working with functions of x here, which means we're going to be integrating with respect to x. And when you integrate with respect to x, your limits that you are going to be doing only require x values. So we're okay. Now, if you're integrating with respect to y, then you would need the y values. Okay, now we're ready for step 2. We're ready for step 2. Step 2 is setting up your integral. Okay, so we're going to start with our lowest x value, and then we're going to move up. Actually, I take that back. My lowest x value is not 0. My lowest x value is actually negative 4. And then it's going to stop at the next x value. So my first integral is going to go from negative 4 to 0. Then we're going to put plus, and we're going to do another integral. This one's going to pick up where that last integral left off at 0, and then it's going to go until it gets to the next intersection point. Now, if you had another x value over here, then you would have to do a third integral. But with 3 intersection points, you're only going to have 2 integrals. Now, that makes sense because let's look at our graph here really quick. With 3 intersection points, we really only have 2 areas we need to worry about. We have this area here, and then we have this area here. And each one of those is an integral. The first one goes from negative 4 to 0, and the next one goes from 0 to 2. So we have 2 areas and therefore 2 integrals. Now the next thing we have to do is we have to know which function comes first. Remember, when you're doing a calculator, it's really chill. All you got to do is put absolute value, and it doesn't matter what order you put the functions in. But when you're doing it by hand, it does matter which one you put first, because we're not going to use absolute value bars. Okay? So you need to know which function is on top and which function is on bottom. So how do you know which function is on top and which function is on bottom? That's an important question. We should probably even write it down. Okay. The way that you know is you're going to pick a number in between your two endpoints here of -4 and 0. So pick a number on the interval. And plug it into each equation. The one that gives you the biggest answer, that's the one that has the bigger y value. Now, if the y value is bigger, that means it's the one that's on top. So if f of your number is greater than g of the number that you picked, then f is on top. Likewise, if g of your number is greater than f of your number, then g is on top. So that's how you're going to know which one comes first. So for this interval, let's pick a number between -4 and 0. Now, -1 is a pretty nice number to pick, so I'm going to go ahead and plug in -1 here to both functions. So if I plug in -1 here, that's going to give me -1 plus 2 plus 5 minus 1 for a total of 5. Now I'm going to plug -1 into the g function. If I do that, I'm going to get -3 minus 1, which is -4. And as you guys can see, the f function wins. It's taller, it's bigger. So therefore, the f function is on top. And so we're going to say it's going to be the f function. And right now I don't have a lot of space, but I am going to have to write the function eventually. It's the f function minus the g function on this interval. Okay, now you're going to do the same thing for the next integral. We're going to pick a number on this interval, though, from 0 to 2. This time I'll pick 1, and we'll plug that in and see which one comes out greater. Now, a lot of the times, it's just going to come out opposite, but it won't always necessarily do that. So you still need to check. But usually it's going to come out to be the opposite of what we had. So in other words, this one's probably going to be g minus f instead of f minus g. But let's go ahead and do it just in case, because it doesn't have to happen that way. They don't necessarily have to switch positions. All right, so if I plug in 1, I'm going to get 1 plus 2 minus 5 minus 1. 3 minus 5 is -2, so -3. Plugging in that one, we get 2. So as you guys see, yes, g comes out to be bigger, so this one's going to be g of x minus f of x. I guess we can put our dx's in there. And that's the end of step 2. All right, so step 1, set the functions equal to each other to find out where they cross. Step 2, set up your integral. The limits are the first things you want to do. The limits come from step 1. The next thing you want to do in step 2 is you want to figure out which function goes first in each pair, and the way you know that is by picking a number in the interval, plugging it in, see which one comes out greater and which one comes out smaller. All right, now step 3 is old news. Integrate as usual. Integrate it as you normally would, okay? And so that's going to take a little bit of time, but that's okay. That's what we're here for. So we'll go ahead and go through this one now. Let's begin. Now I'm going to erase all this just for the sake of having some space. All right, so here's the first thing you're going to do is, so instead of putting f minus g and g minus f, I went ahead and put the actual functions in there. All right, now the next step we're going to do is I'm going to distribute the negative into the second set of parentheses for each one of these integrals, and then I'm going to combine all the like terms. Now they should come out to look exactly the same, with the only difference being that they're opposite signs completely. So the one on the left is x cubed plus 2x squared minus 8x. The other one's exactly the same, it's just all opposite signs. Okay, so now we're ready to do our usual task, which is the fundamental theorem of calculus. So step one is of course to integrate each one of these things here. So I'm going to integrate this, and I'm going to integrate this. So let's go ahead and see what that looks like. Okay, and so this is what you would get if you would have integrated those. Now the next thing we're going to do is we're going to do our usual thing where we do the fundamental theorem of calculus. It's going to be a lot of numbers here, so organization and setup is key. You want to be nice and neat. So we're just going to go ahead and plug our numbers in here. So if I were to plug in 0, all of those numbers are just going to become 0. So I'm just going to put a 0 there. But if you were to plug in -4, I think we can kind of work our way through that one a little bit. All right, if I plug in -4, I am fairly certain we're going to end up with I want to say 64, but it's going to end up being a negative, if I'm not mistaken. No, it's going to be positive. All right, next one. The next one's actually going to be -128/3. And then the last one there is going to turn out to be a -64. And so these are just going to cancel out. That's kind of nice. So why don't we just get rid of those now and save ourselves some trouble. Continuing on, we're going to plug in the 2 for the next set. That's going to be 16/4, it's a -4. And then plugging in 2 here, we get 8 times 2 is 16, so it's going to be -16/3. And then plugging in 2 to the last one is going to be 16 overall. And then when we plug in 0 to all three of those, the whole thing's just going to become 0. So that's nice. We're good there. All right, we can start simplifying things. The next step is to distribute the negatives that you have. So like for instance, I'm going to distribute that in there. So that becomes a 128/3. And by the way, after you do your negative distribution, distributing negative to 0 doesn't do anything. But after you do your negative distributions, you can get rid of all the parentheses and brackets and everything. And as we've said before, at this point, you want to combine things that are the same. So for instance, -4 and +16, we could put those together because they're both just whole numbers. That's a 12. And then 128 minus 16, that's going to be 2, 1. All right, so I've got 112/3 over, or I'm sorry, plus 12. And next thing we're going to do is we're going to go ahead and, you could maybe just leave it like that, I guess, but I'm going to go ahead and go one step further and get a common denominator here. So it's going to be 112/3 plus, if I put this 12 over 1, multiply the top and bottom by 3, I'm going to get 36/3. And then by adding these together, I'm going to get 8, 4, 1/3. And that would be our answer there. So that's the total area. Now all that's old news. We've done that before, but really just want to make sure you guys got the idea here of the steps to solving the problem. It's the first 2 steps that are the most critical. Step 1, find the intersections. How do you do it? you set the functions equal to each other and solve. Step 2, you're going to set up your integral. How do you do it? You're going to be using the answer from step 1 to make your limits on the integrals. And then you also have to figure out which function's on top so you know whether it's f minus g or g minus f. And you just do that by plugging in a test point to see which one is greater. After that, you just solve it as usual using the fundamental theorem of calculus. And that's how you can find the area between two curves without a calculator. Now you're definitely welcome to use a calculator to check your work afterwards, but today, in contrast to the rest of this unit so far, I do want you guys to be showing your work to do these problems, okay? So let me throw some up for you guys to practice. There's 2 of them. All right, so here you go. I'm giving you one that's a lot like mine, then I give you a trigonometry example. Why don't we handle these things one at a time? You guys go ahead and do number 1. Pause the video and try that one. When you unpause it, I'll show you the solution to 1, and then we'll hit up number 2 after that. All right, final answer is 32/3. Yours on this problem would only have one integral. Let's start from the beginning, though. You set the functions equal, subtract everything to one side, factor, solve. You get these limits, 3 and -1. Since there's only 2 limits, you only end up with one integral. You start at -1 and you end at 3. I went ahead and did the g minus the f because on the interval from -1 to 3, I picked 0 as a testing point. And when I plugged that in, I got g is greater than f. So the g comes first, followed by the f. Next, I went ahead and moved on to step 3. So I distributed my negative in here and combined my like terms. Then I integrated. Fundamental theorem of calculus, do your basic math, and you end up with 32/3. All right, let's move on to the second one here. Knowing your unit circle, so if you have your unit circle, it'll be really helpful in step 1. Remember, sine is the y value and cosine is the x value. So if you set these equal to each other, sine x equals cosine x to solve for where they intersect, you're looking for where the sine value equals the cosine value, which means you're looking for where the x and the y value are the same. There are 2 answers on the interval from 0 to 2 pi. So see if you guys can do it. Pause the video here and go as far as you can. When you unpause it, you'll see the solution to that one. Okay, so the final answer is 2 radical 2. Now let's see how we got there. Step 1, set sine equal to cosine. And what that means is we're looking where on the unit circle does the y coordinate equal the x coordinate. And that would be here and here, which is pi over 4 and 5 pi over 4. Those are your solutions. Now over here I put an alternate method. You start with your equation. If you divide both sides by cosine, you get this, which gives you a new equation with just tangent. And you have to look at your unit circle also to know where tangent equals 1, and that's also at pi over 4 and 5 pi over 4. Next, we move on to step 2. We set up our integral. The lower value, pi over 4, goes in the bottom. The higher one goes in the top. How do we know if it's sine minus cosine or cosine minus sine? Well, we pick a number between those. So here's pi over 4. Here's 5 pi over 4. You can pick any number you want to. Maybe you picked pi. I chose pi over 2. And at pi over 2, sine is greater than cosine. And so it's sine minus cosine. Then we integrate. The integral of sine is negative cosine. And the integral of cosine is sine. And then we do our fundamental theorem of calculus and plug these numbers in, evaluate. And you should end up with 2 radical 2. All right, so there you guys have it, and that's our lesson. So we'll call it a day there. Till next time.